for computer instead of a really complex HDMI and HID signal switching. Right. So I built a prototype based on the hardware block, and I'm using this called the UDP, USB Design Package for testing. After more iterations, I end up with a design like this. So it's like the smallest footprint I can physically make it possible. I call it the port unit, so just one port connected to one computer. And then I make a development kit with 2 ports. So I got 2 port unit made, and then an orange Pi03 for controlling both of these port units in this prototype. So after some 3D printing and casing, I got a working KVM device with 2 ports. Next is that we need to work on the IP-KVM software in Golang for Linux kernel 6.1 above. And for those who never worked with kernel before, I will try to go through it briefly. You can ask me afterward if you are interested in details. So because, as mentioned, we can't use a kernel module or kernel patch, so we have to work with the Linux standard drivers like v4L2, ELSER, use the ACM devices. So I'm targeting Linux kernel 6.1 because this is the Linux kernel that's supported by most of the major ARM SoC manufacturer. So that's why I will work with the v4L2 and ELSER here. And for those who never heard of v4L2 and ELSER, v4L2 is a Linux kernel API for video capture devices. So if you insert webcam, HDMI capture card tuner into Linux, it will go through this router, this driver here. And for our capture card, it will expose a dev video. And it will output YUV422 and MJPEG using mmap, so shared memory between the device and the kernel space. And for the ELSER, it's a Linux kernel audio subsystem. It outputs something like dev SND and something device path right here. And in our capture card scenario, it outputs 48 kHz interleaved PCM data. So we have to work with these 2 data to figure out a way to stream it to our web browser. And streaming HDR video to web browser is pretty straightforward, I would say. You first of all grab it from the device video file and then rip the mmap buffer, so you get an MJPEG frame to work with. And then optionally, we can compress it to save bandwidth, and then throw it to the Golang NetHTTP webmux. And then finally, it will appear in your web browser as an image element, so a JPEG stream in the image element. So the library I'm using here is called Go for VL2. It is a v4L2 Golang abstraction library. So it handles the grabbing data part, so it grabs from the kernel memory to the user space and provide a byte channel for me to work with to DQ buff and do a compression and send out, something like that. I skip a lot of details here, but after some coding sections and then it works. Now I can use an IP address to directly access the remote screen using an MJPEG stream. And next thing is the audio, right? The audio is a little bit more complex because there's no library in Golang for it. So I'm using an A record here, and it extracts directly the byte stream for 48 kHz PCM data. I use this command here just for your reference, and then it works pretty similar to what we would work with the video devices, but now we have to pass through this ARE record because we don't have anything to place it in Golang. And then in our Golang application, we read the PCM into the buffer, and then we do downsampling. So we convert 48 kHz to 24 kHz or 16 kHz to save bandwidth. And then we throw it to the WebSocket server, where it just throw the PCM frames directly to the browser. And in the browser, we use the same routine as the USB KVM. We use a WebSocket client to get those PCM frames, usually 40 ms frames, and then we throw it to Audio Context API for rendering to your laptop speakers. And that way, we can directly get the audio output from the HDMI capture card to your browser. And after a few prototyping as well, and then we kind of get it working, now when we click a button, we can start streaming audio to your browser using the ELSER subsystems. Okay, lastly is how do you send USB keyboard and mouse event back to the remote server, right? Because we need state keeping here, so we have to implement the whole thing in Golang in the backend side. It's basically the reverse process of how we send video and audio device to the front end. So we have a browser, we get all the JavaScript events, key click event, mouse down event, mouse move events, throw it to a WebSocket server in the backend, and then the backend will convert the JSON data into the JavaScript event bytecode, and then we do the same thing as the USB KVM does, convert it into HID bytecode, package it in the command, and then through the Linux USB subsystem, and then go over to the CH9329, which is the USB UART to HID cable converter chip. So this part is basically the easier part because I just need to convert the JavaScript code into Golang code and then package it into a Go module. And now I work with a pretty basic prototype, and then I could already see multiple streams on the UI, adjust the audio quality and video quality, as well as sending keyboard and mouse event to the remote server using just a basic web UI here. And obviously, the UI is too basic, so I also write code some better UI for it. Now I have like relative cursor mode, settings, inverse scroll wheel, etc. So a lot of details what we have on the USB KVM started to migrate over to this slide right here. Due to time limitations, I skip tons of details here. For example, like how do you identify each of the port units on the Linux subsystem using USB device tree path and common prefix, or what is the bandwidth used by the USB 2.0 subsystems. So I'm also working on the USB mass storage support. So now you could kind of send files using a web browser to a remote server by emulating, switching the USB device between the host and the remote computers. So now this project is really in its initial stage. So I really need some contribution to make it happen. If you are interested to have contributed to this project, feel free to scan this QR code and join our development. If you have any question, you can feel free to ask me as well. Thank you.
Quick questions.
Yes.
So you say you have the idea and use the port code to do the rest.
Yeah.
So do you run the port code in your Orange? I guess it's Orange Pi.
Yeah.
Or it's a computer, because you have several devices together. How do you let the port code do the debugging for you?
You mean how I run the classical for the...
Yeah. How to deploy the port code so that it can check if it's running, if it's not running, how to
All right.
do that.
So if you look at the hardware design, I actually left a USB Type-C port here. Right? So this port is actually a debug port where I can use a Linux PC and then connect a few of these together to let the AI agent to actually have the access to the hardware level. So obviously, I don't work on the Orange Pi directly. Right? The Orange Pi is for testing. So I work on the PC and then I push it to my own Git server and then pull it down on the ARM server, ARM board, to test it there, and then get the feedback back to the AI agent. This is how I usually work with hardware if needed. But most of the hardware level or hell layer, hardware abstraction layers, is handwritten. So AI only do the UI and RESTful API kind of things. Any question? Yeah.
Can we just use a fast PI to replace those hardware?
You mean a single Raspberry Pi and then skip all these port units?
Because your device need a USB port,
Yeah.
and you need a HDMI port,
Yeah.
right? And you need a different port.
Yeah.
So one PI.
Yeah, I mean, Orange, the Pi KVM project is already using the Raspberry Pi for the IP-KVM solutions, right? But their implementation have a major problem is that their software stack can only work on Broadcom chip because of the kernel, device tree, and configuration, etc. So in theory, yes, you can use a Raspberry Pi 4 to be the brain of the IP-KVM, but the problem is that if you use that, your projects can only run on Raspberry Pi. And Raspberry Pi, is getting more expensive recently. So you kind of need to, find an alternative solution for that. Right? Yeah. Yeah.
I have two questions.
Yes.
The first question is that your in the slide you emphasize two single port computer. One is Raspberry Pi and then the other is Orange Pi.
Yeah.
Yes. Will you please compare what's the difference between these two classes of single port computer, and then will you please for example for Orange Pi, I know that Orange Pi is so popular in mainland China.
Yeah.
It's the number of model right here.
Yeah.
Yeah. So will you please compare
why Raspberry Pi or why Raspberry Pi, right?
Yeah,
Like
yeah.
there's a very big difference. The major difference is in the kernel space and the silicon vendor binaries. So if you want to kickstart or you want to start an ARM SoC from bootleg, right, bootloaders and stuff like that, you need to have a lot of things like device tree, drivers for their peripheral subsystems, and these drivers are not the same on all ARM SoCs. So although on top it might be Debian or Armbian, but in the bottom layer you might have different way to interact with those hardware. So most of the vendors provide a common layer called V4L2 or sometimes GStreamer or ELSA system. This system gives you an API in user space to work with them, right? And in IP-KVM terms, because it needs to have access to specific hardware, if you, most of the project out there directly change the device tree configuration, so it boot differently, I would say like that. The boot flow has a little bit different. So if you use other projects like DezKVM, they have dedicated some changes in a non-open source way in their drivers to use the encoder, the video encoder, to capture video input. So they don't need extra chip for that. But in this design here, because I'm moving everything from kernel space to user space, so it requires additional hardware to make it happen. So in your question, is that what's the difference between Raspberry Pi and Orange Pi in this use case, right? In this use case, they are the same because I designed the system so that it works on pretty much any user space out there with ELSA, V4L2, and USB subsystems. But other projects out there have a limitation on it might only work on a certain type of SoC or only a certain type of API interface, the kernel application binary interface. So in my use case, they are the same, but in other use case, it might not work on special, for example, only work on Raspberry Pi or on Orange Pi, something like that.
The second question is that you mentioned that your Orange Pi is using and the distribution is Armbian,
Yeah.
correct? And this is Singapore Computer Business Distributions. I would
Yeah.
like to know that as a part of open source of field, do you classify this as open? Because they're based on the Debian.
Yeah.
And then customize it for our Singapore computers.
Yes.
As a single part of an open source part of build looking for this distribution, can you say that this is still open source distribution? Because that I find that there's some that when the application updated, package updated,
Yeah.
there was some source of the repository is other than Debian.
Right. I mean, that's quite normal, right? Because usually ARM SoC support are quite limited, for example, 3 years or 5 years. So the vendor will keep the kernel only for like kernel 6.1 to kernel 6.12, maybe something like that, right? So if you do apt-get or apt-update,
Yeah.
it will pull from the public repository instead of the vendor repository.
Yeah.
So most of the ARM SBC, you cannot just use apt-update to update the OS version because of the vendor lock problem, right? And the vendor lock problem is based on ARM licensing problem, so it is really hard to really solve it in the open source term. But I think the Armbian team is doing a great job in packaging everything together. Yeah. So sometimes it might not work, but if you try to stick with upstream, like kernel upstream drivers and things, and try not to update your kernel that much on a specific ARM SoC, it should be generally fine.
Something I would like to share the experience because they are using a lot of Orange Pi Single computers.
Yeah.
When I use it to try the Armbian and distribution, I found the distribution is standard. When I try to update package, something the system will crash because
Yeah.
the package.
Yeah, this is quite normal. I just don't update it. Just you need vendors, the silicon vendor direct support for updating. So it is really hard to update the open source way.
Thank you.
Yeah.
How many versions of Raspberry Pi did you try? You choose Raspberry Pi 4 in your distribution in your slides. What about the older version? Say
It's due to I don't choose Raspberry Pi 4 because of the SoC of the system. I choose it because of bandwidth reasons. So because each of the port unit require around 100 to 120 megabyte per second bandwidth. So some of the Raspberry Pi have a center hub, like PCIe 2.0 times 1 to USB hub conversion on board. So if you have something like that, it actually all the USB ports share the same bandwidth, right? And then if you accumulate that, then it might not work because of the bandwidth limitations. Yeah. So it's not always a digital problem, it's like bandwidth problem.
What about 5?
5.
Do you have a 5?
It's too expensive, I can't afford it.
Can
Yeah,
you
yeah.
share another alternative?
Does it mean that this whole solution can have multiple Windows open, controlling different computers from the single IP-KVM?
Yeah, correct. As soon as you have enough USB port and enough bandwidth, you can use an x86 PC to connect like 100 and I think it's like 255, right? Maximum USB downstream. Yeah, and then each of the port you need use 5 downstream ports, so you can just calculate backward to see how many USB devices you can support out here. But in theory, as soon as your bandwidth is okay, it should be fine.
Actually, can this solution be confirmed that I don't want to use the ARM SBC, I use Dongle x86 computer to as
Yeah, I developed this on x86 computer, so it works on both systems, right? But you usually won't use x86 as your IP-KVM, right? It's power hungry, and then a lot of legacy reasons it might not be as stable as the ARM SoC system. If you have any more questions, you can find me outside the lecture hall. I will be available here this afternoon. So, okay, thank you.